Your washing machine is engineered to fail at exactly 1,095 days. That is 3 years. Not 3 years and 1 month. Not 2 years and 11 months. 3 years. The manufacturer calculated the precise point where the unit survives the warranty period, dies shortly after, and forces you back to the store for a replacement. This is not a theory. This is documented engineering practice backed by internal memos from appliance manufacturers showing component lifespan targets measured in cycles, not years. The washing machine industry transitioned from building machines that lasted 25 years to building machines that last 36 months, and they did it deliberately to maximize replacement sales. We are going to expose the specific components they weakened, reveal the financial incentives that drove the change, and show you how to identify the rare machines still built to last. The planned obsolescence timeline is visible in failure rate data that appliance repair technicians track across brands and models. Machines manufactured before 2005 show catastrophic failure rates below 15% at 10 years. Machines manufactured after 2010 show catastrophic failure rates exceeding 60% at 5 years. The decline is not gradual. The decline is a cliff that corresponds to specific engineering changes implemented industry-wide between 2005 and 2010. These changes reduced manufacturing costs by $40 to $85 per unit, while simultaneously reducing expected lifespan from 15 years to 3 to 5 years. The cost savings went to shareholders. The replacement burden went to buyers. The first engineering change was the switch from metal transmission gears to plastic gears. Washing machines operate through a transmission that converts motor rotation into the agitation and spin motions that clean clothes. Traditional transmissions used machined metal gears designed for 10,000 hours of operation under load. The metal gears could handle the stress of spinning a 40-pound wet load at 1,200 revolutions per minute without deforming. Modern transmissions use injection, molded plastic gears designed for 1,500 to 2,000 hours of operation. The plastic gears cost $8 versus $35 for metal gears, but they strip under the same loads that metal gears handle without stress. The failure pattern is predictable. You load the machine normally. You start a wash cycle. The machine agitates correctly. When it enters the spin cycle and accelerates to maximum speed, the plastic gears cannot handle the torque. The teeth strip. The transmission loses drive connection. The drum spins freely without engaging the motor. The machine displays an error code. The repair requires replacing the entire transmission assembly at $400 to $600 including labor. At year 3, when the transmission fails, the repair cost approaches 70% of replacement cost. You buy a new machine and the cycle repeats. The second engineering change was the elimination of the suspension system. Traditional top-load washers used a suspension system with 4 heavy-duty springs and 4 shock absorbers to isolate the spinning drum from the cabinet. This system allowed the drum to move freely during spin, while preventing the cabinet from walking across the floor. The suspension components were designed to last the life of the machine. Modern front-load washers and high-efficiency top-loaders use minimal suspension with lightweight springs and no shock absorbers. The cost savings is $25 to $40 per unit, but the reduced suspension causes catastrophic bearing failures. The bearing failure occurs because the drum is not properly isolated from the cabinet during high-speed spin. The drum makes contact with the cabinet. The contact creates side loads on the main bearing. The bearing is designed for radial loads, not side loads. The side loads cause the bearing race to deform. The bearing develops play. The play increases until the bearing seizes or the drum contacts the cabinet and tears the tub. The repair requires complete disassembly and costs $500 to $800. At year 4, when the bearing fails, replacement is cheaper than repair. The third change was the switch from mechanical timers to electronic control boards. Mechanical timers used electric motors and cam switches to control wash cycles. The timers were simple, repairable, and lasted 20 years. Electronic control boards use microprocessors, relays, and solid-state switching. The boards cost less to manufacture at $15 versus $45 for mechanical timers, but they fail at dramatically higher rates. The failure mode is moisture intrusion. Washing machines operate in humid environments. Moisture condenses on the control board. The moisture creates electrical shorts. The shorts damage microprocessor pins and relay coils. The board stops responding to inputs or sends incorrect signals to components. The control board failure appears as random behavior. The machine might start mid-cycle. It might refuse to drain. It might overfill and flood. The user calls for service. The technician diagnoses a failed control board. The replacement board costs $200 to $350 installed. The failure typically occurs at 2 to 4 years, which coincides with warranty expiration. Manufacturers classify control board failures as electronic component failures excluded from extended warranty coverage. You pay out of pocket for a failure caused by inadequate moisture protection in a device designed to operate in a wet environment. The financial incentive structure explains why every major manufacturer implemented these changes simultaneously. Whirlpool, GE, Samsung, and LG are competing for market share, but they are not competing on longevity. They compete on features, capacity, and energy efficiency because those attributes sell units on the showroom floor. Longevity does not sell machines because buyers cannot evaluate longevity at the point of purchase. The manufacturer that builds a 20-year machine gets the same sale price as the manufacturer that builds a 3-year machine. But the manufacturer that builds the 3-year machine sells the same customer 6 machines over 20 years instead of 1 machine. The repeat purchase revenue is worth more than the reputation for durability. The comparison to machines built before planned obsolescence reveals what manufacturers deliberately destroyed. A 1985 Maytag washer uses a belt drive transmission with metal gears, a heavy-duty suspension with 4 springs and 4 shocks, and a mechanical timer with no electronics. The design is simple. The parts are robust. Repair is straightforward because the machine was engineered for disassembly and component replacement. Owners of these machines report 25 to 35 years of service with nothing more than belt replacements and periodic cleaning. The machines are so reliable that a secondary market exists for used units selling at $200 to $400, which is 30 to 60% of the original purchase price after 30 years of use. The modern equivalent is a $600 machine that lasts 3 to 5 years and has zero resale value because buyers know the failure timeline. Over 30 years, the 1985 Maytag cost $600 initial purchase plus approximately $400 in maintenance for a total of $1,000. Over the same 30 years, the modern machine costs $600 initial purchase times 6 to 10 replacement cycles for a total of $3,600 to $6,000. The manufacturer converted a one-time $600 revenue event into a recurring revenue stream, generating 6 to 10 times the original sale value. This is the financial engine that drives planned obsolescence. The protection strategy for buyers is to reject the modern market entirely and seek out the machines manufacturers no longer want to sell. Commercial-grade washing machines designed for laundromats are still built with metal transmissions, heavy suspension systems, and mechanical controls because laundromat owners cannot afford machines that fail every 3 years. Speed Queen is the last major manufacturer selling residential machines built to commercial specifications. The Speed Queen TC5 uses a metal gear transmission, a full suspension system, and mechanical controls. The machine costs $1,200, which is double the price of a comparable capacity machine from Samsung or LG. But the expected lifespan is 15 to 20 years based on the commercial duty cycle the components are rated for. The total cost of ownership analysis proves the Speed Queen is cheaper despite the higher purchase price. A $1,200 Speed Queen lasting 18 years costs $67 per year. A $600 Samsung lasting 3 years costs $200 per year. Over 18 years, the Speed Queen costs $1,200. The Samsung costs $3,600 for 6 replacement cycles. The Speed Queen saves $2,400 while delivering better performance because commercial machines are designed for heavy daily loads, not the light, occasional loads that most residential users generate. The alternative strategy is to buy used machines from the pre-planned obsolescence era. Maytag washers from 1980 to 2005, Whirlpool direct drive washers from the same period, and Speed Queen machines from any era are available through classified ads, estate sales, and appliance rebuilders. A reconditioned 1990 Maytag costs $300 to $500 and will outlast 3 new machines. The parts are still available through appliance parts suppliers. The repair procedures are documented in service manuals available free online. You can maintain these machines yourself with basic tools and no specialized knowledge. The industry will continue selling disposable machines as long as buyers shop based on purchase price rather than cost per year of service. They will continue engineering components to fail at the warranty boundary because the business model depends on replacement sales. But the physics of metal versus plastic has not changed. The durability of mechanical systems versus electronic systems has not changed. The machines built to last still exist in the used market and in the commercial segment. Stop rewarding manufacturers for selling you planned failure. Buy the machine engineered to last 20 years, and you will be washing clothes in the same machine when the people who bought the disposable option are on their 7th replacement.